lakes and streams of aquatic vegetation has been compared to the equivalent of clear-cutting a forest. The rusty also is known to eat walleye and bass eggs, and he predates heavily on macroinvertebrates affecting stream ecology. What we have observed from our efforts in the Clear Fork seem to suggest that Orconectes rusticus is a dominant species in the Clear Fork itself, below the covered bridge, and in the areas we have sampled. In the tributaries of the Clear Fork, such as Pine Run native, Orconectes samborni and Cambarus robustus dominate, and in smaller unnamed streams, Cambarus cavatus was found. The fifth species, Cambarus tomai, was not found in our samples, and its specific habitat requirement of tomai suggests that we won't find him in the Clear Fork. We at LHS will continue to develop some baseline data on Orconectes rusticus. We feel this is important and hope others will look more closely at crayfish also.
So let's seine Pine Run, a tributary of the Clear Fork. Procedurally, we have set up our seine, in this case a 3 by 16 foot seine, downstream from the area we want to collect from. We support the bottom of the seine with rocks to assure the seine positioning on the stream bed. 2 people support the seine at either end. The rest of the class moves upstream. We then all move toward the seine, as you can see, moving rocks and disturbing the substrate. The seine picks up much debris and is difficult to hold during high flow. Along with detritus and rocks, small fish, insects, and crayfish are moved into the seine. We carefully pick up the seine and quickly observe what we've collected. We then move toward the stream bank, picking out the specimens we want and releasing the rest. We usually sex and ID the crayfish at this time.
Back in the lab, we can identify the crayfish. Let's first of all distinguish between the 2 genera, Orconectes and Cambarus. Cambarus and Orconectes can easily be distinguished by looking at the rostrum, the anterior extension of the carapace. In Orconectes, the margin of the rostrum has spines, or tubercles. In Cambarus, notice the rostrum's margin lacks these marginal spines. Another significant difference between Orconectes and Cambarus is found in males. In this male Orconectes, notice the hardened branched gonopods. Notice in a Cambarus male, the first and second gonopods are hardened and hooked at a 90-degree angle on the distal end. Now that we can distinguish between the 2 genera, let's look more closely at an Orconectes. First, let's look at the Orconectes rusticus. Notice the rostral spines. Secondly, look on the caudal lateral region of the carapace and notice the rusty spot. These are present on all Orconectes rusticus. Orconectes samborni lacks the rusty spot on the caudal lateral region of the carapace. Another easy field mark is the ventral lateral surface of the carapace being dark in appearance. Other differences exist between Orconectes rusticus and samborni, but these are sufficient for field identification. We located 2 Cambarus in the Clear Fork and its tributaries. There are several ways to distinguish between the Cambarus species. First, let's look at Cambarus robustus. This large, robust crayfish has a rostral margin that gradually converges anteriorly. Also, notice the 2 rows of 6 to 8 tubercles on the mesial region of the palm of the chela. The second species, Cambarus cavatus, was difficult to find in the mainstream. It has a rostral margin that abruptly constricts anteriorly. Can you identify these crayfish? Fish are an excellent determiner of water quality. Just as we know stonefly nymphs, hellgrammites, and many mayfly nymphs cannot tolerate anything other than clean, oxygenated water, this is true of fish as well. The greater the water quality, the greater the diversity of fish species found in the water. Thus, tolerant species like carp, white suckers, blunt-nosed minnows can all be found side by side with brown trout, red horse suckers, and darter species. The key is the tolerant species don't dominate in numbers. Sampling for fish is labor-intensive and equipment-intensive. Ohio EPA currently uses electroshocking as a method of sampling waterways for fish species. An electrical current of 8 amps is extended into the water through a metal D-frame net. When the electrical field is intersected by a fish, the fish is shocked and floats to the surface where he can be netted and identified. One drawback of electroshocking is the possible mortality associated with the activity. Ohio EPA estimates a 5% mortality rate with some species, showing more or less tolerance than others. We electrofish twice a year at LHS, in the fall when low flow is experienced, and in the spring under higher flow conditions. We videotaped some electroshopping footage you might enjoy viewing.
It is important for the students to remain behind the shock net. You'll notice students are wearing waders and latex gloves for their safety. Notice we start downstream and work upstream. It is important to hit specific habitat within this stream to get a wide diversity of fish species. Many fish prefer in-stream cover like fallen trees or other debris in water. Shocking these areas usually produces good results. We always have greater success during the low flow in the fall because many fish are congregated in deep pools and among fallen trees. It is also more difficult to net the shocked fish in the spring due to the fast-moving water carrying the fish away from us. Some fish are found exclusively in runs and riffles. In the fall, true riffle areas are hard to find in the Clear Fork due to low flow. Here we see various darters, hogsuckers, and brown trout shocked from a run below the covered bridge. These fish are well adapted to positioning themselves facing upstream and can withstand strong currents. Deeper pools are excellent habitat for many fish. The lack of deep pools with the cooler temperatures is a limiting factor for many intolerant species such as brown trout and various red horse suckers. In our traveling to the Clear Fork below Pleasant Hill Dam, we've noticed a lack of deep pools. Here in an area above the covered bridge, we shock up many red horse suckers, crappie, smallmouth bass, and rock bass. After the shocking, we spent
First, we have a quillback carp sucker who is in poor physical condition. This fish has many lesions on it, eroded fins, and a partially healed gash anterior to its dorsal fin, where a great blue heron has attacked it. Here is a black bullhead, a tolerant fish species. Found in heavy cover, he too has eroded fins and lesions from where leeches have parasitized it. Notice his belly region. He has been eating well. Many types of red horse suckers are found in Ohio's rivers. This is one of the more tolerant species, the golden red horse. We shock these in large numbers in the Clear Fork. Here, Dwayne Davis discusses how to distinguish a golden from other red horses. The black red horse is a very intolerant fish who needs good water quality to survive, not as common as goldens in the Clear Fork. Notice the distinct subterminal mouth. This is the intolerant short-head red horse. Finding these indicates good water quality. Notice the red caudal fin, less numerous than the golden red horse in the Clear Fork. The next fish is a white sucker, a very tolerant fish. Large numbers of these indicate poor water quality. The next fish is one of our favorites. It's a hogsucker, a moderately tolerant fish found in runs and riffles. He positions himself on the substrate facing upstream waiting for a meal to come his way. Well adapted to fast-flowing water, he can actually flip rocks over looking for crayfish. It is a tradition at LHS to have a student kiss a hogsucker each year. Here, Anne Marie Allarding earns the privilege. It's hard to stop with just one kiss. Our next fish is one the Clear Fork is famous for, the smallmouth bass. He does have some eroded fin problems. This fish is well suited for a stream environment. Notice his bulging stomach. He has been eating well. We found several gizzard shad the smallmouth threw up after he had been shocked and netted. This is common to us all. It's a carp, a very tolerant species. We find them in heavy cover during low flow. We have shocked many larger carp, and there have been reports of people being killed by carp that fly out of water when shocked. Another commonly shocked fish is the rock bass. Notice his distinct red eye. A fish not well suited to a stream habitat is the largemouth bass, preferring lakes and ponds. Occasionally, we find them below the dam. They often can't find enough to eat and perish. Lastly, a crappie. We find both black and white. You distinguish them by counting spines on the dorsal fin.